So good afternoon, everybody. My name is Dennis Kadowitz. I'm with a company called Dynamics, and we have been providing technical services, consulting and training for mining companies in particular over the many years, and we have now moved into power generation along with our friends from Hyperwira, Junaidi and his team. And we have Dr. Andrew Cox on side as well to help us with bringing the subject matter to your attention. Junaidi, perhaps you'd just like to give a brief overview of Hyperwira?
Yeah, Hyperwira Aditama is the Indonesian company. So in last 5 years, we focused a lot on power generation and mining in Indonesia. So we try to develop the knowledge in power generation. So that's why we working together with Dynamics to have a course to improve the knowledge, because now the coal-fired power plant in Indonesia is a lot of power plant, that a new power plant. So I believe we need more information about it. Okay, Dennis. So I think it's time for Andrew, Mr. Cox, to start the webinar. Please.
Yes, Andrew, perhaps you can go on. Andrew will just give a little bit of an overview about who he is and where he comes from.
Good morning, good afternoon, good evening, wherever you are. My name is Andrew Cox. I'll briefly give you a very short biography of myself, and before I get into the webinar proper. So I did my BSc, MSc and PhD in the United Kingdom, did my doctorate at the University of Newcastle upon Tyne. I then did various research at Newcastle upon Tyne and the Universities of Durham, looking at coal, the various properties, the future strategies for coal in the United Kingdom, and the environmental, economic, technical aspects of coal's development. I then went to work for a company called Coal Information and Consultancy Services in the early 1990s, and I became a director. One of the jobs I did there was I edited a newsletter called UK Coal Review for a few years. Subsequently, in 1995, I formed my own business called Energy Intelligence and Marketing Research, which I continue which has been working until today. In the 1990s, for about 20 years, I was a visiting lecturer at Imperial College London. I used to lecture on a wide range of issues to do with coal utilisation. I've also been a visiting lecturer at various other UK and international universities. Some are listed there, such as Leeds, Manchester, Sheffield, Newcastle upon Tyne, the Open University. I also have lectured at other international universities, such as in Finland and in Colombia. I've also been involved in a wide range of consultancy and project work to do with climate change, environmental issues, clean coal technology, mining, economic projects, also to do with virtual reality, to do with mining safety, and also recently I've developed an international ports directory and database. Over the last 20 years, I've developed a range with clients and with other training companies and universities. I've developed a range of continual professional development courses, and these are, some of them are here, 6 of them are here listed, which I can now offer with Dynamics and its partners. The first 2 I'm going to describe today, that's called Properties, Blending and Safety. The second one is coal stockpile management, and some of the other courses are an introduction to clean coal technology, also to look at a more advanced coal-fired plant, supercritical and ultra-supercritical coal-fired power stations, circulating fluidized bed combustion, petroleum coke, biomass and waste fuels, and also for those countries which are developing it, I can also offer a training course and continued professional development on carbon capture and storage. So the first course that we'll briefly describe today in this webinar is about coal properties, blending and safety. The main elements of this course are, we will look at coal as a fuel and to provide an overview of global coal production. The course will also look at in detail coal sampling, coal sample preparation, the laboratory analysis of coal and the various analytical techniques which are available for coal producers and coal consumers. We'll also be looking at coal stockpiles and blending, look at the wide range of fuel and handleability issues which power station and other coal users can experience. And finally, we'll look at some of the key safety issues. For instance, we'll help people develop, do a review and an overview and revision of risk assessment and safety issues. And we can look at some of the key issues to do with the safety of coal, particularly spontaneous combustion, and also looking at some of the issues such as the safety around coal conveyor belts and coal silos. Each year, billions of coal are traded either within countries or internationally for use in power generation, for use in the production of steel, cement, and various other industrial sectors. Just to remind you, coal is a very heterogeneous material. It has a very wide range, varying range of organic and inorganic matter, and it exhibits a wide range of physical properties. And the price of coal not only reflects the quantity of various properties and how they affect the performance of the coal under the various operating conditions. So the properties of coal often form the basis of the sales contract, and the payment for the coal is based on the analytical results. So when you buy a coal, the quality, the properties of the coal, and which are based on the analytical results of what you'll pay for in the coal contract. The analysis of coal, which we will examine in this particular course, for people who and subsequent ones, well, the analysis of coal is generally performed on coal samples taken from bulk material and not from individual components. So given the complexity of coal, the various sampling protocols must provide material that is representative of the cargo that is being sampled. This is extremely important. And to ensure that a representative sample is collected, correct sampling procedures and rules have been developed, and these have to be followed. So coal analysis procedures should also be sufficiently accurate so as to preclude, to avoid negative scientific or economic consequences. So one of the key issues is to avoid bias in sampling methods. And on the bottom of the page there, it shows you, for instance, one automated sampling piece of equipment, which can automatically take bulk samples from conveyor belts. You can also, there are also sampling techniques, automated sampling techniques that can remove coal from other bulk commodities. All coal analysis should follow standard procedures in order to obtain repeatable and reproducible results. So the commonly used testing and techniques for routine coal analysis are either proximate analysis or ultimate analysis. And the various elements of these testing procedures and how you produce these analyses will be described in detail throughout these particular courses. And on this particular slide here, I give you a montage, a selection of images which shows some of the laboratory equipment that are used in producing proximate and ultimate analysis. There are also now available more advanced instrumental analytical techniques. So conventional coal analysis usually involves work in the laboratory on the laboratory bench scale. And while it's expected that these particular technologies will continue for the foreseeable future, it's well worth remembering now that there's now a wide range of new modern equipment, modern instruments that are available, which can provide wide-scale applications. And these techniques now use a wide range of different technologies. For instance, X-ray spectroscopy electron microscope technologies, atomic spectroscopy, mass spectroscopy, neutron activation analysis, and other technologies. And many of these techniques are fast, they're very sensitive, they're also very simple to operate and have low detection limits. And if they're properly calibrated and used properly, can provide very highly accurate results. So a proportion of the instruments are capable of also determining multi-elements simultaneously. So some of the equipment and technologies can provide accurate data on several elements within a coal sample simultaneously, which is obviously much quicker and much cheaper than many traditional techniques to use in the laboratory. So instruments provide minimum sample preparation and can also be used on site, which is also obviously provides very rapid analysis and very rapid results. So many of these instrumental methods have been developed and adopted by national and international standard organizations for standard tests for coal analysis. And other instrumental tests are now applied to coal analysis by companies and in laboratories throughout the world. Some have now standard international standards. Some are in the process of obtaining them. So this is a moving and developing area of laboratory and on-site analysis, and these technologies will be described in detail in the course, and we can provide more information on particular techniques to meet the requirements of particular clients. One of the key issues, obviously, that will be examined in the course will be, for instance, the development and the use of coal contracts and the various specifications which are included within them. Here's the sample page from a coal contract for Indonesian coal being delivered from Kalimantan, which shows the chemical analysis for a range of elements, a range of materials which are specifications for the analysis, which are included within the contract. For instance, the moisture content, the ash content, the volatile matter, the carbon, fixed carbon, the total sulfur, the gross and net calorific value, and also the grindability index. And the full course material includes actual examples of recent contracts highlighting available coal specifications. And we can provide contracts from a range of different countries: Indonesia, South Africa, Russia, Australia. Of imported and domestic coal is also extremely important and has taken on extreme importance over recent decades. So until recently, coal blending in power plants was mainly adopted to reduce the cost of generation and increase the use of indigenous or readily available coals. So lower grade coals can be blended with higher grade imported coals without deteriorations in thermal performance of boiler plant. And this can help reduce the cost of generation, either at a power station or an industrial plant, or for other uses such as cement and steel manufacture. So in some cases, coal blending is used as a form of pollution control, such as in the combination of different coals to ensure compliance with sulfur emission limits. There are many different methods of coal blending which can be used. Coal can be blended at the mine. It can be blended at a washery or coal preparation plant. It can be blended at a shipment plant, say at a port or at a delivery port. And it can also be obviously blended at the final consumer, such as at a power station stockyard. The blending methods that can be used can depend on the various site conditions, the level of blending that is required by either at the production at the mine or at the final consumer, the quantity that can be stored and blended, also the accuracy that is required, and also the end use of the blended coal. So the various courses that are on offer determine the different reasons and priorities for coal blending, and these include methods for blending, for coal characterization through mixing and storage, and also include some case studies in different and in challenging conditions. This particular course Key stages in risk assessment will be assessed and examined, such as in coal transport and handling and storage. And these will range, we'll also be looking at, for instance, some of the issues to do with coal handleability, the vessel-related issues, risk assessment and safety to do with coal stockpiles, conveyor belts, and coal storage facilities. And the best available best practice covering coal assessment, risk assessment, and health and safety will be examined for coal operation during the course. There are several important safety issues that plant operators should evaluate when they're handling and storage coal. One of them, which we'll be examining in detail in the various options and the various units, will be about self-heating and spontaneous combustion. This is a problem in many countries, particularly some countries and some coal-exporting countries. This can have significant problems both for coal producers and for consumers, not only due to the obvious health and safety issues, but also to the potential loss of valuable assets that can take place, and also to do with the releases of various gaseous pollutants which can take place during coal self-heating and during. So one of the other key issues that we'll be looking about is about coal issues. There are no widely accepted or rigorous definitions of coal handleability, but basically it refers to the ability of the coal to flow unhindered through processing and transportation systems. Handleability can be adversely affected if coal particles, finer coal, stick together, aggregate, and stick onto various surfaces. And handleability problems can occur throughout a power plant or industrial sites. And it can cause difficulties in unloading coals from ships, from vessels. It can also, coal can stick to the walls of hoppers and bunkers and cause blockages. Also, they can get the gradual buildup of coal on conveyor belts, which can lead to equipment failures and health and safety issues, and spontaneous heating and fires. All coal plants can have handling problems, but as that particular illustration, which I took from a publication which I used in the early 1990s, it's worth remembering that some plants can have handleability problems can be worse than others. Also to remember, if coals are used in power plants, challenging properties, they can have challenging properties and characteristics, and the plants must be well designed and modified to cope with them. So power plants and industrial facilities using coal can also have very complicated layouts where multiple coal handleabilities can occur. So throughout the plant, the type of lining materials and handling systems have to be carefully designed and modified to cope with the type of coals that they'll be using. So that covers a very brief overview of the first course that we can offer. The second course is on coal stockpile management, inventory systems, and the various technologies. Here's a quick view of the key points that we'll be dealing with. We'll be looking at developing and operating coal stockpiles. We'll be looking at key related sampling issues, analysis and auditing of coal stockpiles. We'll be looking at the way coal deteriorates and the various quality issues that can take place when coal is stored and in stockpiles. We'll be looking in considerable detail about spontaneous combustion and about the various causes and how it can be controlled. We can also look at the coals from particular countries. One of the countries that we can provide in detail is the coal from Indonesia, particularly from Kalimantan, which is the major internationally traded coal within Asia and the surrounding regions. We can also look at, and we'll be covering the various dust emission and prevention measures that can take place on coal stockpiles and also for facilities that import and transport coal. One of the other issues that we'll look at, which I'll describe in a few minutes, is about the issue of flow slides, how they can occur on coal stockpiles and how they can be reduced. And also in the course, I won't deal with these in detail, but we will also be looking at stockpile management plans and also about the various models and computer models that are available that coal management plans can be developed and successfully implemented. If we now move on to stockpile management, this is the part of coal handling processes all the way from a mine, all the way to the power plant. So all producers and consumers use stockpiles at their facilities, either to serve as buffers between material delivery and processing, or to act as strategic stocks, which can help companies deal with supply interruptions, or to enable coal blending to meet various quality requirements. So basically, coal stockpiles are extremely important to have a wide range of different uses. So with mounting pressure to minimize capital tied up in stockpiles, there is a need to optimize coal inventories. There's some images which are shown either on the previous slide or on this slide, which shows some of the various types of stockpiles and the type of equipment to use for basically for stacking and reclaiming, and also for so depending on the capacity and type of power plants, factors such as stockpile size, turnover period, timely stock management, and the ability to take advantage of cheaper coals and other fuel sources have assumed greater importance, and these will be examined throughout the various course units. We now move on, quickly look at coal stockpiles. These are carried out at a number of points, as I mentioned, along the transportation chain, from either the user all the way to the various end user. And as I mentioned before, these can either be at a mine, coal washery or coal preparation plant, at transshipment points and terminals for either importing and exporting coal, and at the various end user sites, such as power plants, steel plants, where you produce coke, cement plants, or various industrial facilities. So just to go over the main functions of a stockpile, they serve as a buffer between material delivery and processing. They act as strategic stock against short and long-term interruptions of supply. And they can also homogenize and allow the blending of coal to provide an even feedstock to meet a required quality. And experience over the last few decades has shown that with good stockpile design and management, most coals can be stored safely and in an environmentally safe manner. So the development, I've given you here an image showing you a subbituminous coal stockpile in the United States, having a chemical sealing layer added to reduce oxidation and to reduce self-heating and spontaneous combustion. And this type of technology will be described within the course, and I can provide detailed information on the range of chemicals and sealing products that are available in particular countries throughout the world. So one of the things we'll be describing in this particular course in the various units will be about stockpile management. We'll be looking at the type of equipment that is used in stacking and reclaiming operations. We'll be looking at the shape and the building of stockpiles. We'll be looking at water sprays and chemical sprays to reduce dust emissions. We'll be looking at compactions of stockpiles to minimize oxidation and self-heating and spontaneous combustion. And we'll be also looking at monitoring of stockpiles and inventory management to minimize and prevent spontaneous combustion and the deterioration of the various coal qualities. So here's some images showing coal stockpiles in Australia being sprayed with water or chemicals to reduce dust emissions, which is obviously a very, very important issue if, say, a coal stockpile or stock heap is in close proximity to other industrial users or, say, urban areas. Coal stockpiles can be partially or completely covered, this is obviously quite important. So bulk storage sheds are one operation, one particular option rather, for cold storage. I'll show here, for instance, an example of a cold storage shed, a large facility in the Philippines. And this can provide significant protection against heavy rainfall and adverse weather conditions, which can obviously occur in most countries, but particularly areas which are prone to cyclones, hurricanes, and other extreme weather conditions. An increasing number of power plants and other consumers have also produced large storage domes to ensure all-year protection of coal stockpiles, and which also can prevent particulate and dust pollution issues. And I show you an image here from one dome where you can either have one or multiple stockpiles, and where the coal can be either reclaimed, use stacking or reclaiming equipment. Unfortunately, these dome structures can be unsuitable if the coal is subject to self-heating and of, say, carbon monoxide, methane, and other gases. So other storage facilities, other storage sheds, or arrangements are recommended where coal is subject to those particular problems. One of the other issues that we'll be dealing with in the course options will be about looking at stockpile auditing. Periodic coal stock audits are carried out by all companies to reconcile the amount of coal in stockpiles to their various book inventories. So the stockpile tonnage is determined by measuring the volume and the density of the coal that's in the stockpile. And both the book and the measured inventories are subject to various measurement errors. And these errors can represent significant amounts of money. So the course will examine a range of different issues for auditing. The errors associated with the book inventory value, the total quality measurement, the various weighing measurements and weighing systems that are used, coal density determination, and that's quite complicated, it involves a range of different factors, the various standards that are used to use throughout auditing, volume measurement, for instance, using laser technology and other technologies, and also the various computer models and computational facilities that are used in working out the final tonnage. So we'll go through these various issues using case examples to help people understand the various issues that are involved in auditing. One of the other key issues in the course that we'll be looking at is about conveyor belt design and the best practice that are used for them. Each year, fires occur on conveyor belt systems at power stations and cold storage facilities throughout the world. These fires cause financial losses to the plant operators and sometimes can lead to serious injury and loss of life to personnel. And by using best practice, nearly all of these fires can be avoided. And so what we'll be doing in the course, we will be looking at best practice and helping people within the courses identify the various issues that they can use to ensure that they can reduce fires and other health and safety issues towards with the use of conveyor belt systems. So when coals and other fuels are prone to spontaneous combustion, then best practice conveyor belt operation and maintenance is essential. Additional material is included in the course, for instance, on fire monitoring for conveyor belts, and this can include the installation of carbon monoxide and methane monitoring systems, and also temperature sensor equipment. So as an old material handling engineer told me once, he said, experience shows that the only 100% safe conveyor belt system is one that is actually switched off. Conveyor belts should always be treated with care. And this is a particular feature, particular issue that we will mention over and over again within the particular course units. Other issues that are important are site dust control technologies. Dust generation is the term used to describe the process whereby fine coal particles become detached from the bulk of a coal material to form a cloud, which can then be dispersed by wind and by airflow. And within this, in the course, this particular course units, what we will do will help people taking the course identify particular trouble spots within coal storage and handling facilities. We will look at dust control measures and the various technologies that are available. We will look at the factors in developing risk assessments, also looking at dust pollution action plans, how they can be developed and their key issue and their key factors. And mostly also equally important, we'll be looking at health issues. We will identify the range of equipment and the range of issues involved where to help site personnel reduce their inhalation of dust and to help and protect their health. And we'll also be looking at the various equipment available for dust protection of site personnel. The other key issue to do with dust, and which we'll provide a separate unit on, is also about the issue of dust explosions. These can cause serious damage and also cause loss of life on site. So what we will be doing is we were looking at the various causes and how to prevent dust explosions. When people store, particularly have large coal storage areas, one of the issues that can take place is that you can, coal stockpiles can suffer flow slides. Stockpiles are prone to, they can be prone to instability, and basically the sides can collapse, and also various slides occur which material can flow down them. And these can cause a range of health and safety issues for the site operators. So what we will be doing on the course, we will be providing risk assessments and risk and safety procedures available to help develop in the minimization and to reduce the potential hazards to both personnel and also to the various equipment that are used. And potential consequences of a slide can cause increased operating costs associated with cleaning them up. They can cause the loss of production if coal, the debris, clogs conveyor belts, or that causes problems to the stack and reclaimer tracks and equipment. It can also cause damage to the coal handling equipment, and also it can cause danger to personnel and particularly to those working on the ground in close proximity to a coal stock heap and coal stocking area. Coal spontaneous combustion is also an issue which we'll examine in detail in this particular course. Subbituminous coals supplied from Kalimantan in Indonesia, as well as other countries, are prone to spontaneous combustion problems. However, Kalimantan coal is particularly notorious for this particular problem. Coal cargo shipped from Kalimantan have arrived at their destination terminals with self-heating problems, where the temperatures of the coal have already exceeded 55 degrees centigrade. Power plants and other consumers of these coal should work in conjunction with the suppliers and the shipping companies to minimize transport self-heating problems to reduce spontaneous combustion. Special instructions have been issued by shipping and insurance companies over the last few years, which cover key aspects of the export of coals from Indonesia. Publication was issued by the Protection Indemnity, the P&I clubs, which are run out of the United Kingdom, and this particular publication was called How to Monitor Coal Cargoes from Indonesia. And these instructions and other key publications will be thoroughly reviewed throughout the course. And I give you, on the left-hand side there, you can see the front cover from that publication, How to Monitor Cargoes from Indonesia, showing fires that can occur. Also, you can see at the bottom a coal cargo showing self-heating problems with steam and gaseous emissions emitting from it. The question is, how do you spot self-heating and spontaneous problems in their early stages? One of the ways to do it is by the determination of hotspot detection using infrared cameras. And these can be used together with thermocouples to detect hotspots in either coal or biomass or other materials on site. And infrared cameras can be used to detect, also be used, are very, very useful, and they can be used to detect, for instance, problems and overheating in electrical equipment and other equipment, and therefore reducing costly fires. For instance, I'll give you an example. On that particular slide, there's an example of a infrared camera, and it shows you at the bottom a coal storage heap, and on the right-hand image, you can see an infrared image of it showing an area where self-heating is taking place. You can, if a plant wishes to make more higher levels of investment, it can install coal pile fire monitoring equipment. These can provide continuous, fully automated operation, and the results can provide high resolution, high accuracy thermal images 24/7, which can provide combined with digital data transmission. So in the control room, the entire scanning equipment can be installed, which can provide continuous information, which can provide straight to monitoring equipment in the control room, such as the thermal image, and these can clearly identify hotspots, which can then activate pre-programmed alarms to ensure immediate action is taken to prevent the onset of heating and spontaneous combustion fires. And the course will provide information on the information that can be provided to the plant operator from these type of systems, the coal pile fire monitors and their key features, and also the benefits of these particular systems. So that's the end of the overview. During the course, we can also provide more detailed analysis of particular issues to meet the requirement. All the full courses contain case studies. They contain a wide range of images and illustrations, and I'll provide links to a wide range of other data and further reading to help people do follow up after the end of the course. So at the end here, if people wish to contact Deca Dynamics or our partner in Indonesia, Hyperwira, there's contact details. One other final point, we can also, when requested, we can provide a short multiple choice assessment at the end, at the completion of each course, with a selection of questions covering the key issues to assess and assist in the delegates' understanding of the materials that have been taught. And the test material, the various tests can be provided in the language of that the clients require. So at this point, I'll now hand back to Dennis, who will now take over the question and answer session. Thank you.
Thank you, Andrew. Can you hear me clearly?
Yes, I can hear you, yes.
Super, thank you. So thank you, Andrew, for that. As you can see, it was a short presentation on two of the main courses that we're offering to power generation companies and other companies interested in managing stockpiles and coal sampling. For our Indonesian clients, you're welcome to contact Hyperwira in Indonesia, and for other clients around the world, you're welcome to contact us at Deca Dynamics here in Australia. You'll be able to contact both of us on our websites. For those that have joined the meeting from an email that was sent to them, you have our contact details there, or you can find us on www.decadynamics.com.au. There you go, and www.hyperwira.com. What I will do is we're going to make take this recording and put it onto our website and onto a YouTube channel, our YouTube channel, so that will be available for everybody to have a look at and refer to. We look forward to hearing from you if you're interested in discussing some of the matters further.